Okay, so my name is Ashok. I have 20 plus years of experience in information technology. The last 3.5 years in big data and related technologies, analytics, data science, and things like that, IoT and all that. So I look forward to spend the next 1 hour with you and really looking for an interesting journey for the next 1 hour. So let's get started, friends. Thanks for coming again. Yeah. So today's topic, as you can see, it's quite interesting. Um, Hadoop and necessity for data science, right? So let's get started. So just a minute. So what will you learn today? If you look at it, let's have a quick poll. Do you know the following? Like, what is big data Hadoop? What is a data product? What is data science? Why Hadoop for data science? Is Hadoop a necessity for data science? So these are all the things we are going to see that in a nutshell today. So I'll try to cover how much ever possible, friends. So I have like 20 odd slides, and that also includes a demo towards the end, right? So Mohit, okay, voice. So friends, are you anybody having audio issues? Thanks for the confirmation, friends. Yeah, everybody seems to be perfect. Even Mohit also just clarified to me. So he's just doing a check at his side. All right, fine. Not able to hear anything, so I'll Kaustav. All right. Others can hear me. All right. So friends, what we will do, you know, what we will do is uh, we will the structure of this today's presentation, right? The way I want to keep it is, let's go over the deck because I know everybody's inquisitive, and I'm sure everybody has got questions, correct? So but just in the interest of time, and and also in the interest of the audience, I don't want to disrupt the flow of the session, correct? I don't want to disrupt the flow of the session. So what I will do, I will take you through the session. Please allow me to do that, right? And you can always bring up questions, when we have questions at towards the end. So what I will do, before I go to the demo, I'll pause for question Q&A for some time. Then after the demo, we'll have Q&A as well, correct? And I'll try my best to wrap it up in 1 hour, correct? That's the agenda. So what is big data and Hadoop, correct? So this is the first thing we are going to see. Big data is a popular term used to describe the exponential growth of data. Can be structured or unstructured or a combination of both, right? So what we are saying is, it can, if you look at the today's stats, right? This is a no-brainer. The data is coming from various sources today, right? We have varieties of sources, whether it is an application server or a web server, or from all these devices like Fitbit and you know uh, any kind of IoT devices, or any kind of uh, network devices, correct? And all the social media sites. So everything is, it uh, the data is coming out of that, correct? And these are the things which we can no longer ignore these things, right? Because uh, in the past, it was just one database and very structured way of collecting the data. Now the data collection, or it starts from the instrumentation all the way up till you know uh, visualization. So when the data collection happens, right? So we want the data to to live to live forever, right? Because we have realized the value of the data, we have realized the potential of the data. We don't want to shell the data or archive the data, correct? Because we want the data to be available for analytics all the time, correct? So we have you know thought through various architectures that can actually hold the data forever, right? So if you look at the stats again, it is predominantly 80 to 90% of the data in the world today is unstructured, and the data is exponentially growing as mentioned in this slide, right? And if you look at the velocity of the data, which is the growth, you know, at which the data is growing, right? The pace at which the data is growing, it is phenomenal. It is just a simple example. New York Stock Exchange, they are saying they are generating like 1 terabyte of new trade data every day, correct? 1 terabyte of data, right? Which is nothing. If I tell you a few other things, these things get dwarfed by that. Right, the Hadron Collider, correct? It's one of the largest particle colliders. They are doing a big experiment in Switzerland, right? So those that collider generates about a petabyte of data every 3.5 seconds, correct? Phenomenal amount of data. Phenomenal amount of data. This is a very famous definition you all would have seen, the dimensions of big data, represented in three V's, right? One is the velocity, real time, right? The rate, the pace at which the data is growing, and volume. It's like, all the social media. If you look at Facebook, if you look at Twitter, you look at Tumblr, Instagram, all these sites are growing like crazy, right? And you are talking about, they're processing millions of queries, and Twitter is like having 500 million tweets per second, sorry, per day, correct? It's 500 million is staggering, right? So that's the kind of, and we have about, 500 million CDRs we are processing, called data records, right? So everything is like, the volume is staggering, correct? The volume is staggering. Okay, all right. So, and the variety, we talked about it, right? We talked about the variety. We said from what sources, we are getting, and we are getting structured, unstructured, and semi-structured. We have lots and lots of varieties. We are also uh, getting this data, correct? Variety is also playing one of the, and one of the fourth dimensions which we haven't mentioned here, which is there in your IBM, is just which is your uh, can you all guess it, friends? What is the fourth dimension in the four V's? Veracity. Okay. Can someone tell me what is veracity? What is veracity, friends? It's a very interesting one. Truthfulness. Fantastic. Truthfulness, right? Fact-based information. Can you give me an example? It's just a lovely thing. I mean, what I personally feel is, it has to be accorded the same amount of respect what we give for velocity, volume, or variety, right? Because truthfulness, if some field got missed in the database, it should still process the data. Is that what it is, Abhishek? Okay. Truthfulness, or the, you know, the validity of the data itself, right? Validation, correct, right? The validity of the data, or if there is any certain uncertainty in the data. Can you give some kind of, can you give me an example which happened quite recently? Quite recently. Can you give me that example that happened in the automobile industry? I just gave you all the clue in the world. Volkswagen, fantastic, Abhishek. Yeah, I think you're all emission scandal, right? Correct. Fantastic, friends. Volkswagen emission scandal. So they just fudged a small device, right? They fudged a small device so that it will, whatever the emission of nitric oxide, it goes undetected in the emission test, whatever that is done in the research labs there, right? So they just fudged that. And people are, it came up with flying colors. And the same guys, they tested BMW upside down, they found that to be extremely successful. And they also certified Volkswagen, especially the Passat model. And see what has happened, right? It is a case of veracity, right? The truthfulness, if there is any ambiguous data coming in, right? The whole thing, friends, what I'm saying is, if the data is uncertain, if the data is ambiguous, whatever coming out of the data, it may still make sense to you, because, and you may make a, you may derive some insights, and based on the insights you will come up with a product decision, or you may come up with a major business decision itself. So that may prove to be completely wrong if the data itself has got some issues, right? So that's a classic case. Thanks for explaining, friends. I think you're all right up there in understanding this veracity part. Yeah. So Hadoop is a programming framework that supports the processing of large data sets in a distributed computing environment. First and still the best tool to handle big data. I think there are lots and lots of tools today, right? Today people are talking about Spark, people are talking about Storm, people are talking about Spark streaming, people are talking about Flink. I think you'll have lots and lots of derivatives and lots and lots of flavors coming out of Apache. Hadoop still continues to be one of the most powerful ones, and Hadoop's the uh, investment is close. It will get closer to $2 billion by 2020, and it's growing at a staggering rate of 58% year over year, right? So there's no way Hadoop is going down. There are a lot of misconceptions. People say that Spark is going to overtake. It's not like that, because Spark is in-memory computing, and Hadoop is for a different purpose, correct? So I mean, Hadoop can handle elephants. That's one of the reasons why they put the elephant here, right? So it can just take any amount of data, right? And what is the difference, friends, between Hadoop and your traditional RDBMS? Can someone tell me quickly? Any fundamental NoSQL database? Okay. All right. Can handle unstructured data. Fantastic. Yeah, that's the kind of difference I want, friends. The framework. Yes. And distributed file system. Excellent. Correct. Unstructured data, distributed file system. Okay. That is OLTP. This is OLAP. Correct. Fine. Schema on read, schema on write. I think you guys are rocking here. Correct. Works in different code moves to the data. Brilliant, Anshul. Yeah. Lots and lots of great points are coming in. I mean, other thing I wanted to talk about was the architecture piece, right? With Hadoop, right? It is more a scale out architecture, not a scale in architecture, scale up architecture, right? It is scale out architecture, meaning if we need to go, right? I mean, if I am expanding, the data size is increasing and all that, it is more a horizontal scaling, not vertical scaling. Exactly, correct. So that also, it's one of the differences. And of course, a lot of people mention that I'm taking the program to the data, not the data to the program. That's one of the significant differences, correct? Hadoop was the first till the best. Okay, sure. Brief history of Hadoop. 2004, Yahoo creates 2005 under E14 to work on Hadoop. Apache project established. Yahoo begins to operate at scale. Hortonworks data platform. Okay, focus on innovation. Actually, when Yahoo started it, and later it became a full-fledged Apache. It was uh, became a full-fledged Apache platform. It was incubated and became a formal launch, correct? And I think as we speak, I think we are running 2.72, if I'm right, because every day things are evolving, right? Things are moving pretty fast. So it used to be 2.6, then I saw 2.72, one of those formal releases. I don't know what it is today, but it should be around that 2.6 plus, right? 2.6, 2.7 types, correct? So it provides, Hadoop provides a lot of fantastic features. It provides economy on scale, and it provides reliability through fault tolerance, and it provides flexibility. And these are some of the standout features of Hadoop, correct? Most efficient for large scale storage and processing, correct? Distributed file system and self-healing data store, correct? And MapReduce distributed computation framework that handles the complexities of distributed programming, correct? So we have this computation co-located with data, so that makes it special, as many of you pointed out. Data and computation system co-designed and co-developed to work together. You all would have seen the name node and the resource manager. Name node is the master daemon for storage, and resource manager is the same thing for processing. They actually sit in the same server in a distributed cluster, correct? And similarly, on a slave nodes and all that, you have, similarly you have um, data node, and node manager is for the processing slave daemons, right? They do that. So It is one of the frameworks, where they have conquered this, when in a traditional system, what we do, we move the data to where the program is running that actually cripples the network bandwidth and it can crash the system as well. That's why we were doing the archiving and all that part, right? And we take only part of the data because we cannot afford to slow down the network, right? So we did all those things because we didn't have a proper architecture in place to handle a high volume data, correct? So now with the advent of Hadoop coming in, now we know how we can do this. So because the data and computation have become together, right? So the compute layer, the program itself is taken to the place where the data is located. So this feature is called data locality, right? It's a very one of the most significant standout feature in Hadoop. Data locality really makes it very powerful, right? The data is never moved, the program is moved, right? Process data in parallel. The other thing is the data is stored as blocks, right, as chunks in various commodity servers. That also makes it very special in Hadoop, right? So we are able to do things in parallel. Commodity hardware nodes, self-healing, failure handled by software itself, correct? Then design for one write and multiple reads, correct? There are no random writes, optimized for minimum seek on hard drives, correct? And Hadoop provides high throughput and high latency as well, because I think it is I think some of you pointed out that RDBMS is more a OLTP, this is more a OLAP. It is by design, correct friends? Okay, what is a data product? A software system whose core functionality depends on the application of statistical analysis and machine learning to data, correct? So if you look at it, okay, I want to ask you this. People you may know, where do you see this, friends? Where do you see this feature? People you may know. Okay, bingo. All of you are saying LinkedIn, correct? Facebook, okay. Facebook also, yeah, okay, sure. So how do you think they are providing this feature? Facebook, LinkedIn, okay. How do you think they are able to come up? And friends, do you all agree with me? The people you may know, it may not be so, most of the times, at least in my case, right, it is 40 to 50% of the times I find that link to be meaningful and I go and connect with the people, correct? Most of the times. So, I mean, I would say 50% of the times, correct? So that's fairly a good hit rate, right? How do you think they are doing this? Any guesses? Machine learning, excellent, correct? Machine learning says Bhushan, correct? So they should do some kind of, they are definitely running a machine learning algorithm for sure, correct? Machine learning, correct? And they are doing it for, I mean, they do things like, for example, you might have heard about a tool called Mahout, right? It's an ecosystem tool of Hadoop, correct? So that one does recommendation engine, right? There are so many recommendation engines, and they also look at your clickstream pattern and clickstream analysis, and come up with all these things. Definitely machine learning plays a part in this, correct? So they do all these things, come up with recommendation. Even Google ads, right? You would have seen Amazon books. If you are reading this book, it goes and suggests, okay, go and, okay, people also bought this book. It says that, right? People who bought this, they also bought this book. So that also gives a lot of relevance. Sure. So they use that algorithm, correct? So look at this, including results for data science. See again, look at this. This also, where, how do you think they are suggesting this? Okay, regular expression, Taniru. Anybody else, friends? Past clicks, keywords, mapping. Yeah, there are so many things, right? Frequent, correct. Based on popular search criteria, pattern matching prediction. That's the same machine learning. Yeah, machine learning is also there. Pattern matching is also there. Text mining, fantastic. Yeah, they do all these things. If somebody who's doing this, right, it pretty well knows that you're probably, it's just a typo here, and it doesn't auto suggest, correct, with pattern matching with data mining. Fantastic, Samiran. right? So when they do this, right, they also list down the data science things below. They don't waste time by giving you, hey, did you mean data science? Yes, but they already say this is what we are trying to do. But do you want results only for this? They are still asking this. So they are already gone ahead with this, right? So it's all, very intelligent way of doing things through machine learning, pattern matching, as you all rightly saying, data mining, extensive data mining here, right? So what is data science? So we are embarking on what is data science, extracting deep meaning from the data, finding gems in the data. So data mining is hard work. Yes, there's a lot of gems hidden in there. Look at that. So friends, just to give you a small heads up, in good old days, in the beginning of 19th century or even little more onto 19th century, right? Or 20th century, correct? So we were all, people were running after gold, right? There was a heavy gold rush everywhere, right? Especially people in US, mass exodus to California. I think that's how people say, people even found California, right? So there's a lot of science and a lot of history to that. I'm not getting in there. My point is that was the gold. People, there's a big gold rush moment. Then 60s, 70s, 1960s, 70s, and all that, most of the Middle East prospered because, they call it black gold, right? Petroleum and all that. Today, data is the latest gold, right? So without mincing any facts, I'm telling you, if a smart analyst, if that person knows how to mine the data, right? How to mine the data and extract the insights or the gems, that person can go a long distance, right? So that's precisely the nature of the job for a data scientist, right? Given the data, otherwise, the data will exist, right? It becomes like a dumb data, correct? If you can really unearth lot of insights from the data, then it goes a very long way, correct? You can do wonders with that. Look at some of the common data science tasks. Clustering, detect natural grouping. So just to give a small example of that, clustering is also, all about, uh, you look at some patterns, correct? You look at some patterns and group them, correct? That is your clustering. Outlier detection. So again, you look for some anomalies or some bad data, right? Something which is outrageous. So even a data scientist may check with the business analyst, even in this case, because the outlier detection is more like, just to give you a small example, friends, you are doing a, like a mean and median of somebody's salary, correct? Of salary for a particular city, then suddenly the one of the salary goes like a million, right? That person may be acting he may be a rock star there, you know it, you cannot exactly classify that as an outlier, because you need to first, you need to detect the anomaly and still check and take a meaningful decision. Again, affinity analysis, look for a co-occurrence of patterns. Classification, okay, this is like predicting a category, right? Doing a regression, correct? You can do a linear regression, you can do a, logistic regression. There are multiple ways to regress and find out, uh, and come up with predictions, right? Regression and recommendation, predict a preference, what we saw just now. So these are all the descriptive ones, these are all the predictive ones, correct? So building data products, delivering gems on a regular basis. Sorry about that. Pre-process, build model, and periodic batch processing, and throw it onto the SQL. So you can, I mean, this is just a model, so you can use anything here, correct? Why Hadoop? Again, why Hadoop for data science? What do you think, friends? You have seen what is Hadoop, correct? We have seen what is Hadoop, and we got a dipstick view on what is data science. Why do you think Hadoop? Where do you think Hadoop will serve the purpose? Before I go deeper, I just want to put this question to all of you. Provides economy on scale, helps the data scientists, best way to handle high volume data, any kind of data efficiently, right? So size of the data is really doesn't matter so long as we can handle it. big data in a systematic way. Okay, so a lot of people are giving Hadoop can work on humongous data in quick time. So one thing is, friends, as I told you, Hadoop provides high latency. So what I mean is, you cannot hunt down a particular record and all that. It processes things in blocks of data, correct? Blocks of data, high volume of data in a very effective and efficient way. So if I want to read something in RDBMS, right? If you walk across a bank and tell them, okay, here is my bank passbook and this is my name, they will be able to pull your record maybe in a couple of seconds. That is not possible in Hadoop. But if you tell the Hadoop, okay, go and read 5 terabytes of file, it can still do that in few minutes, which RDBMS can probably never do that, correct? It may probably take ages and fail and all that stuff because of scale up architecture, right? Here it is scale out. Sure. So Hadoop is very powerful, and since we are dealing with large volume of data, right? So that is becoming one of the popular choices for even data scientists to work on, right? Data scientists, data analysts, you can have any of these combinations to work on Hadoop. Explore the entire data set. If you look at it, so this is my racks and all that, data processing cycle, storage, data collection. Is Hadoop more scalable? Arun is asking. Absolutely scalable. Correct? Absolutely scalable. So I can go on adding clusters. I mean, commodity servers to my cluster, or I can even have more rack space, more servers. I can keep adding the servers. Exactly. Correct? So explore the entire data set. It's possible. Mining of larger data sets, better outcomes. So the more and more data you have, right, better and better the outcome becomes. Correct, friends? So it is like even it is for a data scientist. Even if you are training a model, for example, a particular algorithm, people always say we train the model, then and the algorithm becomes more stronger. Correct? So they always say that the more and more data, it always yields a better outcome. 80% of the data science work, you will be astonished. So this is the truth actually. Raw data, sampling, filtering, joins, entity resolution, strip away all these things, document vector generation, term normalization, right? 80% of the work is actually involving the cleaning up the data, correct? Data preparation, they say. They do a lot of transformation, when they say cleaning up, right? They set the data because it may come in different formats. It may have some web bots lying there. So they need to make the data, they need to give meaning to the data before the data gets analyzed, correct? So the data has to be in shape. Generally, most of the times the data will never be in shape, correct? So they need to make the data, make it available, and make it consistent so that it becomes good for analysis, correct? What are the, okay, just one question, friends, before I go further. There is a question here. What are the other frameworks like Hadoop for data science? I think, Ravindran, there are a lot of, Hadoop is taken in conjunction with data science because of its ability to handle large volume of data, ability to handle high throughput, correct? All these are plus factors. So people also do, if you're only looking at some regression and all that, I think, yeah, you can look at, R, you can look at SAS, you can look at, some of these tools as well, which provides you a statistical insight onto your, from the data science perspective, correct? So that is one way, but you can always use it in conjunction with Hadoop. That's what we are trying to say here, correct? Okay, RDBMS uses schema and write, whereas change is expensive, high barrier for data-driven innovation. Sure, speed barriers of traditional data architecture. I need new data. Finally, we start collecting. Let's see, is it any good, correct? So RDBMS has lots and lots of schema and write, meaning without doing anything, right? Without doing anything, in the sense, without even inserting the data. Before you insert the data, right, you need the schema in place, so that any change, right, you need to go to the DDL, make all those changes. It is quite expensive, and that's not the way we work today, right? Because the data will come in a very sparse format. The data will be completely unstructured. So those kind of things, RDBMS, BMS are already falling flat here, right? So it is really required for you to have an accelerated data-driven innovation. When the data is predominantly unstructured, you need more flexibility here, and you need, Hadoop especially, it supports schema on read versus schema on write, correct? Things can happen pretty fast and very volatile. Schema on read means faster time to innovation. I need new data. Is it any good? Low barrier, correct? Data driven. So that's precisely what we want, right? If it is a high barrier, meaning there's any changes, if I want to do it with the data, you need to go and make this changes to the schema, everything, right? That's going to tire down or discourage anybody who wants to pursue or who wants to innovate in the data front, correct? So this one is a radical thought. It completely makes it very easy for anyone to move forward, correct? So it accepts anything because the only time the schema is required is while reading it. Okay, before I move on, friends, there is a question here. Can I update a value in thousands of tables in 1.5 terabyte database using Pydoop? Is it Python on Hadoop? Taniru, is that what you're asking? Python on Hadoop. Okay. Thousands of tables. Okay, I've used Python at a very surface level, that too for data science, but not in conjunction with Hadoop, Taniru. But in Hadoop 1.5, can I update a value? No, but what I can tell you, Taniru, I mean, you can, if you're having it in tables, especially in a NoSQL database, correct? NoSQL database, it is possible whatever you're saying. If I'm using HBase or something, database, I just want to just a second, friends. Just a second. Yeah. Oracle DB. Taniru, you want to update in Oracle or you want to update in Hadoop? Which one are you talking about? Oracle. Okay. 1.5. No, it is possible. Why NoSQL DB required when we keep data in HDFS? No, Saumen, the point is HDFS is a file storage. NoSQL is actually NoSQL is actually a database, correct? It is a database. HDFS is a plain file storage. Sure. There is a significant difference between these two things, correct? Sure. Okay. So I just want to understand the set of Hadoop environment is very costly or moderate. Mohit is asking. It's actually, friends. Can I just do the demonstration and come to these questions? Correct. So I will probably finish that because we are not done there. We can, yeah, required. The setup is not very expensive, Mohit. If you have the expertise, I think it's not so expensive because it's open source. Hadoop is open source. End of the day. We can use MapReduce only. Somin is asking. It's not true, Somin. There are things like Spark is there. There is things like Storm is there, right? There are so many processing uh, frameworks are available today. Correct? Okay. So, of course, towards the end, friends, I'm going to do a, please complete the survey once you're done, right? Once I'm done, I would request your feedback. That's going to be very important for us. So let us certifications. I don't know what they have to say here. Okay, there is a big data certification. Okay, you can always aim for this. Batch starts from 17th October. You can give it a shot. Sure. So that is something starting here. Reading and presentation. Okay. So these are some of the features of Hadoop. I mean Edureka. So I just want to highlight this. Then I want to move on to the. Uh, this is it. Just a second. Thank you. Friends, 1 second. So there is a demo. So can I finish this and go to those slides? I think I missed the demo part. So I'll quickly show you, any analyst, right? Data scientist, any data scientist, right? They are quite familiar with all these things, right? They are also technically equipped. Most of the data scientists they have a good background in mathematics or statistics, correct? And they also have a good analytical aptitude. So I'll just show you a very quick, a small program how we, you know, I just want to do a quick analysis. Fine. So friends, I am just doing a quick, I'll show you this demo. Okay. I have a couple of data sets. Okay. I have a couple of data set. One is the customer. Fine. You find all the, customer records are here. This is the customer code. First name, I'm sorry, uh, last name, age, profession. Correct? Sure. And you also have transactions for that customer. Correct? The transaction ID, and you have a date, transaction date, customer code, the sale value, right? Here is the category. Here is the product, and I have the city, state, payment mode. Are you all clear with the data set, friends? I haven't told you what is the problem I need to do, but are you clear with the data set, what I'm trying to say? You have a customer file and you have a transaction, appropriate transactions file. Is that clear so far? Awesome. Okay. Very, very simple. What I want to do, the problem statement is all about for each customer. I have about 10 customers right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 customers. For each customer, I have multiple transactions, right? 4001 is one of the customers. And, yes, that person has Christina, right? Christina has bunch of transactions here, here, 6, 7 transactions are there, right? So for each customer, similarly, I have multiple transactions. Now, all I want to do is to print for each customer. I want to print the name, and I want to print the number of transactions, and I want to print the total number of transactions, total sale value, right? I need to have a sum of all the transaction amount, correct? For the number of transactions. Is that clear? So how would you do if I just give you these two tables in SQL? What's your thought process, friends? What will be your approach here? Write a join. Fantastic. So what will be your joining attribute here? Join and group, exactly. Joining on the customer, correct? So how many lines would you do it, friends? How many lines will be your SQL code? 2 to 3 lines. Okay, sure. Okay, it's not the case in MapReduce. I'm going to show you the program in Java. 4 lines, okay, whatever, right? So it is going to be a little more, it's Java MapReduce, right? It is, if you're going to use joins and other things, right? My natural choice would be to use Pig or Hive, right? They are pretty fast, and they are, Hive, Pig is a declarative language, and it's really quick that way, right? So I'm going to show you in a traditional MapReduce. So as a data scientist, right, one thing what I want to tell you is you need to know which tool to use where, because data scientists, they analyze the data, that's true. They also know, they should know how to optimize an algorithm and all that. They are very scientific too, right? So I'm going to show you in a very traditional Java program, like how we do the joins and other things, right? That's what I want to demonstrate today, correct? So look at this. These are the two files I've already moved into HDFS, correct? This is my HDFS. So if you look at this, these are the two files I've already moved it. Fine. So in my Eclipse, correct, I have something called customer mapper. So I have, like, let me go to the driver class, my main class, right? So I'm saying how to move these files to the HDFS. Okay. I will do a put command, Abdul. I will just say HDFS, DFS, I'll just say something like this. Let me just type the command for you. It's a pretty easy step. I just say HDFS, uh, DFS, put whatever is the file, X file, whatever is the file, right? whatever file, put that in whichever location you want to put it in, HDFS, correct? HDFS location. Is that clear? Hadoop FS put. Yeah, that's right. Correct. So this is my syntax. So this is what I've done. I've already put it. So what I'm doing, friends, the mapper, right? I want you to understand. It's not so easy to implement in Java, but you know it is quite powerful once it is implemented. So I am saying I have got two mapper classes running, right? My first one is like, you know, I'm giving command line argument when I'm going to execute the jar file here once I build the jar. Sure. So my path argument 0, which is 0 based, right? So I'm going to give the location of the customer mapper, which is located in this location, right? HDFS. This is where I have. Sure. Correct. This is my second one. Correct. This is where my transaction mapper is running. Correct. And the third one is the output where what I want to generate for, because that's the problem statement what I mentioned. Sure. Okay. Now Jagdish is saying he has already done big data developer from Edureka. Sure, Jagdish. See, data science, you know, you can go to, you know, machine learning algorithms, that's covered in depth, and you will also get to do a lot of business analytics. Correct? You'll also get into the recommendation engines, business analytics. You will do lots and lots of exercises in R and how to connect, how to work on R in conjunction with Hadoop. All those things are coming in there, Jagdish, right? Sure. Okay. So from my, you know, what I want to do here is I'm going to do a, you know, output path. Like, okay, these are all the standard ones. You know, I'm just giving the output path, which is my third parameter, right? So in the first mapper, what I want to do, I want to split this, correct? I'm writing, I'm reading the file, which is this file. I'm reading this file, sure, and I want to split that into based on the comma, right? It's a string array. I'm giving a string array. I'm doing a record dot split based on the comma because comma is the field separator there. Then I'm writing the mapper's output as this one, parts of 0. Let me just give this. Let me just give this, friends, so that you know it becomes very clear to all of you. This is my mapper's output, right? So what is parts of 0, friends? Just curious to know what is parts of 0 here. All right, you all got it, correct? Parts of 0 is this one, sure. And what I'm writing, this is my key. This is my key. This is my key, and this is my value. This is my value. What is parts of 1 here? First name. Perfect. First name, right? So it is Christina, correct? So this is my cust. This is how it is going to be written. What about the transactions? Can you similarly help me here? In the transactions mapper, what I want to do, record is equal to value to string. Okay, I'm similarly splitting, right? So before I write Christina, right, friends, one thing I forgot to tell you. I also write, this is how I write, right? Customer slash T Christina. This is what I do, right? And in this part, right, transactions, what do I do? Similarly, I'm saying parts of 2. Just give me a minute. Here you go. For the transactions mapper, what I do, uh, this is the one. Sure. This is what I write in the transaction mapper. Parts of 2 is what, friends, here? What is parts of 2 here? Customer ID, correct? Customer ID. So it is 400, whatever is going to come, right? Okay. What is parts of, so I'm going to write something like this, right? Transactions, again I'm hard coding it here. and parts of 3. What is parts of 3 here? Any guesses? The sale value, right? 4733 whatever, right? Okay, now how many times I should be writing for this? For all the transactions, right? All the transactions I'm going to be writing this. Then what happens, friends? I think you all may have basic idea about MapReduce. Some of you may have, correct? Some of you have already done. So can you all try to answer what happens after the mapper's output is generated? What happens, friends? What is the next step in the MapReduce? Sort and shuffle. Jagdish is, since he has attended that, right? Excellent. Sort and shuffle and sort. Okay, sure. So what should happen? Excellent. So what should happen? And then fed to the reducer. Correct. So this one, what I'm saying is it'll come here, right? So this one will come multiple times, friends, because we have for the same customer, I may have 85. I'm just saying, how many ever number we have, right? Just throwing some numbers here, right? So it has 3 times, let's say. Fine. 3 transactions this customer has. So how will be the values generated to the reducer as an input after sorting and shuffling? Do you all agree with me on this? Like it'll create a list of values, right? It'll have something called cust t Christina and let's say I'm sorry, and similarly transactions t slash t 47 transactions t 85 and so on so forth, right? 233 whatever, correct? This is what I will, is that fine, friends? This is what I will have. Is that clear? This is what expected to go to the reducer, correct? This is expected to go to the reducer. Now I want to tell you, in this simple map reduce program, what I'm trying to do is, this is my logic to find out to print the total sale value as well as for every customer, right? That's the idea what we are, I mean, that's the business problem we are trying to solve. So I will iterate on the values. So which one, friends, which one I should be iterating on here exactly when I say values in the reducer? The transactions, all those things, right? This whole thing is my value, correct? This whole thing is my value, right? This is my list, right? So this is my, and this is the key. After it is shuffled, this is my key and this is my value. This is how it is going to be fed to the reducer, correct? So I'm getting this. So I'm parsing this. So I'm saying, I'm again for each value, because I've hard coded just to make a split, right? Because I'm going to split it on T, tab. I could have put a comma also, I'm just choosing to, I'm using a delimiter. Why I'm doing that? Because I want to identify or distinguish whether it is from the customer or the transactions, right? If it is a customer, if it is a transaction, I'm simply declaring a variable, right above this, if you see the code, I'm just having a local variable here, count, right? So I am just incrementing the counter because I need to print the total number of transactions, and I'm also totaling the parts of 1, which is my 47, 85 and all these things. Can you all hear me, friends? Okay. So this is how I do the simple calculation here. If it is not equal to transactions, what is the other option, friends? What is the other option I will have? If it is not transactions, what is the other choice? The customer, correct. So it ought to be customer. If it is customer, the only thing I do is the parts of 1. This is the parts of 0. This is the after slash t. This is the 1. So I'm simply assigning the name to my, again a local variable. So what I do, I have to print the name, and so I'm printing the name as the key, the value as the count and the total. Sure. Are you all clear, friends? So I am meeting the objective of printing for every customer what is the total, what is the total number of transactions they are dealing with, and also along with the total sale value. Are you all clear? Totally clear? Okay. So shall we execute this and see? Just a simple file, right? Let's execute this and see this. Just a second. I'm going to create a jar file. Sure. And let me say advanced ADV jar. Sure. And a minute. Done. Okay. So I'm going here. Look for the ADV jar. It's there. Now I'm going to say Hadoop jar adv.jar. What is my input file name, friends? Let me maximize this. Input file name, I have it in the HDFS. mr input. Here is my path. That's exactly what I give. Sure. Custs mr output. Sorry, mr right join transactions. mr output and let's say right join, and I say data science, right? Let me say ds October. I just want to create a folder October 13th. Sure. Let's try this. So this is the location in which I want to generate the output. Sure. That's exactly where I'm coming to. Done. So I go to the mr output. This is where I generated the file. You can see Christina had 8 transactions, total sale value. Similarly, so many other 10 customers, they're all having transactions, right? So, uh, okay, the relevance is, the data scientists, as I told you, friends, they should know as a data scientist, they are very scientific, as I told you, they fix the algorithm, they optimize it and all that. They also need to know what kind of solution they have to use in different scenarios, right? So this is a simple one, what I showed you, which is using Hadoop, right? Because uh, the storage is Hadoop, and I'm just doing a simple processing in Hadoop. So the data scientists also, they try to use various algorithms, where to use what and all that they need to know, correct? So that in order to analyze or even cleaning up, right? They may use Pig to do a data transformation, because Pig is a effective cleaning up tool. It's a transformation tool. So there are various ways to look at this. So friends, I'll go back to the deck. I think I kind of, just so as I told you, your feedback is going to be super important, and you have these certifications and you have this batch starting up pretty soon. And as some of you asked, I've done big data from Edureka, and it is absolutely data science, pretty vast, and there's a lot of useful topics. I mean, it's a very expansive course again, and you can uh, check with Edureka, what is the course criteria and all that. You can check on that. But now let me take up few questions. We are just at 10 o'clock. Okay. Now I'll take up questions for the next 10 minutes, friends, so that we can end it on maybe 10 minutes from now max. How do they use various algorithm in MapReduce or in the result of MapReduce? So MapReduce is a processing framework, Ravichandran. It's part of Hadoop. When I say algorithm, right, you can use different algorithms to use, first of all, pig also uses MapReduce, right? Hive also uses MapReduce. In certain cases, do you really want to use pig or hive or the raw Java MapReduce? Because if the data is highly unstructured, you may still want to use Java, right? Because Java has fantastic libraries and all that to handle various kinds of data. The course contents, Soumya, now if you're talking about data science, I think Edureka is the best guys to answer this, but I can tell you they definitely cover some of the data science basics, and they go in depth into business analytics, they go in depth into R and all those things, and they also try to cover the Hadoop front on few things, and and you also will be talking about the Mahout and all that. So it's quite an expansive coverage there, right? So I'm looking at the question window, friends, one by one. Can we use Kafka as an input system, which is better? Which is better, Kafka or Spark? Both are different, Anand, right? Kafka, it's like a RabbitMQ kind of thing, right? It can process messages, right, in an asynchronous way. Whereas Spark is more a batch processing, but it does it in memory. Spark streaming is real-time processing. For data science, do we need to have complete business knowledge of underlying data? Bhushan, I think data scientist is more towards technology. I think people, thanks for asking this question, because business analysts, they see there is a subtle difference, right? Data scientists, they fix the algorithms, they optimize the algorithms, right? Whereas business analysts, they need to know which algorithm to use for a business domain or for a business problem, because these guys are also masters in the business domain, right? So there's a subtle difference, but they work hand in hand, correct? And data scientists also, they have a good knowledge on some of the domains, but it need not be the case. So the business knowledge, I would say more a business analyst kind of thing. Data scientists are more scientific in nature, Bhushan, right? More scientific. They are good in scripting, they are good in machine language, they are good in Hadoop, they are good in technology, they are good in some of the algorithms and all that. So that is the Spark, Storm and Hadoop basic difference. So Spark, as I told you, Shreyas, it is more a in-memory computing. Spark streaming is very close to Storm. I think Spark runs on Hadoop again, right? Runs on Hadoop, whereas Storm runs on Mesos. I could be right or wrong here. And Hadoop, as it said, right, it is batch processing, correct? It is primarily for high latency queries. Will recording be available for other course takers? Uh, this recording should be available, Arun Kumar. You want to check with the Edureka support, but I guess this session is being recorded. How much execution time would it take a value need to be updated? Okay, updated in all thousands of tables, 1.5 terabyte of Oracle DB. Taniru, the point is, if you are talking about Oracle DB, right? What I can do, if you want to, if you have such a massive data, I can scoop the data. I can use scoop to bring it onto, something like a Hive data store, right? And I can do I can get the values updated. That is possible, right? 1.5 terabytes is not a, it's not a big data as such, right? Maybe for Oracle, yes, but for Hive, it can take, because any data that is coming from Oracle, right? It's structured data. So I should quickly get it onto Hive, right? Then I can probably update it and send it back to Oracle. So that's one way of looking at it. But if you're going to use Hive as the data store subsequently, then I can very well keep that in Hive itself. When you say how much time, it should not take much time, Taniru. It should be in, uh, if you properly, uh, thousands of tables, I don't think it's going to take much time. I'm not exactly, because it depends on various parameters, Taniru. I cannot say it will take milliseconds, but should take few seconds. That's all, right? Why is both HBase and HDFS are required? Is it either or optional? It depends, Ajit. It is like HBase, I'm not saying it's required. I'm not saying HDFS is also required. In certain cases, if you want to use Low latency latency do queries, go for HBase. If latency is not an issue, go for HDFS, right? HDFS is a pure file store. Do you have any other language instead of Java? Absolutely, Pankaj. You have Python, you have Pig, you have all these things are there, right? Hive and everything. Sure. Hive is a data warehouse system, data warehouse tool. It's one of the ecosystem tool provided by Hadoop, Muhammad. Where is HBase used in your demo? I didn't use it, Ajit, right? I didn't use it at all. Working as a support project Tableau administrator, career change to big data analytics with 1 year with Cloudera. Yeah, it's a tough question, right, Kishore? It is. See, it all depends on everybody's ability also. Uh, so it is like, yes, I mean, on a positive note, I can tell you can definitely make a shift because I would say, Kishore, because you are a Tableau guy, right? You should be good in visualization. I feel so. Maybe you can look at uh, how you can marry even Tableau can connect to Hadoop. Maybe you can look at that kind of portion, right? And how you can bring the analytics overall. You can learn that analytics and how you can bring the analytics all the way till visualization. That is one area you can explore, Kishore, right? Just as a thought. Hafiz is asking, is it similar to SQL? Hive, absolutely. It uses MySQL dialect, Hafizullah. Yeah. When we decide to move to Hadoop, when PhD masters in statistics required for data scientists. That is one way, Tamachari, right? It is not a mandate though. There are folks who can also, but generally people come up with such kind of degrees and all, quite a lot of people, right? But I would say, somebody who has an aptitude for math and algorithms and all that, they are fairly good candidates to get into can be groomed as a data scientist. We can use MapReduce for data, then what is the need of NoSQL DB like MongoDB? Okay, that's something different, right? Data processing is uh, that is processing the data, correct? MongoDB is a storage, right? It's a data store. Both are different. Storage is different, processing is different, correct? Any programs other than Is there any other programs other than word count? Why do you ask that, Malika? There are millions of programs. So many programs are there. For a person better in programming, what extent do you think statistical knowledge is required? I'm dumb in math. Okay. So, friends, I think there is a interesting anecdote or something which I saw very recently in a data science thing, right? So, a data scientist, Jagdish, you don't need to be discouraged at all, right? My point is, a data scientist is generally knows, you know, more statistics than a software programmer or engineer would know, right? And he will know more software engineering practices than a statistician, raw statistician will know, correct? So they know they have a combination of these two skill sets, right? They have a combination of these two skill sets. So they are generally good in math. They have a good analytic aptitude, and they are good in stats, so that they can understand all those stat complex functions, algorithms, regression, and all that stuff, right? So, but it is not a skill which is impossible. It cannot be picked up or anything. Sure. So you can always invest on that. Difference between MongoDB and Hadoop. Yeah, in fact, MongoDB is a NoSQL again, Varun. Hadoop is a file store, right? MongoDB doesn't need to be on Hadoop in the first place, whereas HBase needs to be on Hadoop. MongoDB is a NoSQL database, correct? NoSQL database where it can store data. Hadoop can also store data, but MongoDB and all these NoSQL databases, right? It is fundamentally different from Hadoop or the Hadoop file system in the retrieval process, right? The random retrieval, correct? So those things Hadoop doesn't support, as I told you, right? It comes up with high latency. So any real-time data you want to work on, right? These databases makes it possible. I need some real-time projects. Is it possible for real-time projects? There are lots and lots of projects, Malika. So maybe you can check with the Edureka support. I'm not trying to, make any marketing pitch here, but there are lots of and for you to take a quick outlook, right? You can always go to Hadoop, powered by Hadoop and all that, right? There are lots and lots of companies, they are doing real-time projects on Hadoop. Most of them are using Hadoop clusters. Store the data in file format and process. Sure, Abdul, it's possible. What is Hive? I think I answered you, Hafizullah. Is it similar to SQL? I think I'm again. This was answered. What language do they use for MapReduce, Java, Pig, Scala, real-time projects? I think anything can be used. Java can be used, Pig can be used, Scala can be used, and Python can be used. Can you look into Hive as a career in big data? Absolutely, Hafizullah, it's possible. Yeah, in fact, I come from C++ background, and I understand Java, but there are simpler ones, so I always try to use the simple ones. Correct? Whenever you can use that, you can. Why use HDFS? Why not? I think I've answered this. Hadoop compatible with R? Yes, the answer is R. Yes. Python, I think somebody told me, right? I think one of you asked PyDoop or something. Which one has an advantage? So I would say R has got connectivity with Hadoop. I'm sure Python also has. I'm not, though I haven't used it. I've used R with Hadoop. How important is RAM memory for running MapReduce? Should it be proportional to data sets? I think RAM memory, I think whatever we have, right? A typical Hadoop commodity server, generally if it has like a, uh, 8 GB, this is what we are talking about, right? 8 GB kind of thing we are talking about. So a fairly good commodity server can do the job. Sure. So it depends, how important RAM memory. I'm not, we are not really looking at a very sophisticated machine, but it is, we are not looking at a very cheapo hardware also, we are not looking at a throwaway machine, which you can use it for Hadoop cluster. We have a reasonable good terminal server, which is also very cost effective. Pankaj, 8 years in Oracle, can I switch? Definitely, Pankaj. It's not a, anytime you can switch, because people are moving into big data, people are moving into analytics. Wherever there is data, you'll have analytics, and wherever analytics, and people are gearing up to IoT and all that stuff. It's all cloud, big data. These things are going to be, the future for sure. Data brought to the memory at the time of processing. Ajit, it's a, long story short. The data is not brought, the program is taken to the data, right? Yet he can get project use cases from Edureka support. Jagdish said, okay, sure, Jagdish. Yeah, I'm not okay. I think I've answered this. How I can use complex transaction. I know it's a dumb question, but I knew how long would take Hadoop to an implementer level from scratch. It's not a dumb question at all, Shreyas. I think it takes anywhere between, just if you can take a course, right? It need not be any, I mean, you can just take it at your own, whichever course you want to take, right? Make an effort to do Hadoop, yeah, that's all. Just make an effort to read Hadoop and understand the basics, how things are implemented, and where all they are implementing, and what are all the fundamental advantages. All these things you need to understand. So it takes, for you to have a good grip on Hadoop, right? Anywhere between uh, 3 to 6 months, you know, just to get a good grip, because you need to at least have a couple of implementations for you to claim that you're good. Correct? Average salary data scientist, it depends, Jagannath. I wish I knew this, but but it is considered one of the sexiest job of the 21st century, which is a, everybody says this, but but it's really true. People are, really moving in this direction. So I think people are highly paid in this area. Sure. So okay, necessity, yes. You didn't answer the question yet, Khalid. uh, Yes or no? No, the necessity, yes, Khalid. It is, if you are, because we are talking about data preparation, we are talking about data transformation, we are looking at data cleansing, all these things, right? Hadoop is one of the platforms that can provide seamless integration for all these things. So I feel that, it's one of the uh, one of the favored platforms for data scientists as well. Sure. Spark is going to replace, what do you think? Krish is asking. In fact, Spark, yeah, as I told you, right, Krish, Spark is not going to replace as such. Spark is going to complement it. Friends, as I told you, right, it is like you're not, I mean, a lot of people ask, RDBMS is dying. Yes, it is waning, but it's not going to die. If I can use RDBMS for certain solutions, right, which the data is never going to grow, but I'm going to have extensive querying, I would rather go stick to RDBMS, right? I can use maybe SQLite or MySQL wherever possible, right? And for real-time queries, I can use any streaming data. I can use Spark streaming or Storm. And for data which is like latency is not an issue, which I can get it done in minutes, right? I can park that in Hadoop or one of the you know NoSQL databases. There are lots and lots of solutions. People are looking at not single solution, right? So they are not looking at single data source. They are looking at an assorted solution, because you may have 5 6 business scenarios within your organization. For each scenario you may have a solution, so they want to just put that together and have it as a overall solution. Correct, friends? So it's nothing like one size fits all model. You'll never find that kind of thing going forward. Pig is a data warehousing technology. How will it be useful for data mining? Taniru, the point is Pig is more a data transformation. It's a ETL tool. Data warehousing is more a high-vis data warehousing part. Pig is more a ETL tool to do the cleansing, especially when you can use extensive, the date formats are coming in different ways and all that. You can use that tool to clean the data, right? Using regular expression. It provides lots and lots of features. Sure. It's very easy also, very simple to learn and all that. So friends, I think I hope I was able to answer the questions, because I don't see any more questions here. Um, Hope you all enjoyed the session, and hope you found it useful. And I would request, as usual, just your feedback. Provide your feedback, and we are here to improve further, right? So, thanks for your patient listening. So I look forward for your feedback once you end the session. So please take time and provide the feedback, friends. So for anything on the tech, the recording or anything on the logistics part, check with the Edureka support, and they should be there to support you. And thanks, friends. Thank you so much. I really enjoyed the session with you. Look forward to uh, connect with you sometime in the future too. So thank you so much. Good luck.